Okay, in this video we're going to take a look at the distributive property once again, but we're going to use a little acronym called FOIL. And you don't have to do it this way. It's just, all FOIL is a way to help remind yourself of every combination that you have to account for. And what I mean by that is, here we're multiplying two what we call binomials. We call them binomials just because there's two terms in each grouping. But if I've got two terms in this grouping, and I'm multiplying it by two terms in this grouping, I can think about this like this. 2 times 2 gives me 4. There are 4 combinations that I'm going to have to be aware of. Now, if you can find all 4 of those combinations without this acronym, go for it. This acronym is designed to help remind you that they're there. So the first one, F, stands for first. That means I'm going to take the first term in each grouping and multiply them. So here's the first. X times x gives me x squared. O stands for outside or outer. So I'm going to take the ones on the outside edges. X and negative 9 are on the outside edges. And when I multiply those, remember the negative goes with the 9, it's negative 9x. Now the one that comes next is I. That's for the inside, so the ones on the inside edges. 5 times x is positive 5x. And my last one, that's what L stands for, is the last term in each grouping. So 5 times negative 9, which gives me negative 45. Now when you do this, sometimes that's as good as you can get. You might have 4 separate terms and none of them go together. But in this case, I look at this and I go, you know what? Now at the end, it's just like my adding and subtracting. I've got 2 terms that both have just an x, so I can cram them together into one, and this becomes a negative 4x. Okay, notice I didn't change its identity. I just said how many of these terms are there. So I have x squared minus 4x minus 45. Okay, and that is my resulting polynomial. Now in a future lesson, we're going to learn how to go back the other way and take this thing and rewrite it this way. And the reason we're doing all this practice is sometimes it works a lot better if I can make it look like this. And it's real simple to use. Other times, in certain applications, it might look better this way. And so we just need to be fluent in going back and forth between all those combinations. Let's look at one that has some numbers in it that we didn't see before. Now you notice this one's got a 2 in the front. Don't let that affect your process. Start with F first. So I take my first 2 terms. 2x times x is 2x squared. Remember, I'm multiplying these things together. My next one is O. That's my outside. So 2x and 7 are on the outside edges. So that gives me 14x. Then I get to I, which is my inside ones. So it's negative 3. Remember, the negative is attached to that 3. Negative 3 times x is negative 3x. And then my last one here, L, L is going to be my last term in each grouping, which would be negative 3 times 7, negative 21. Okay. And as we look at what we have left over, well, we still have a couple of terms that happen to be the same. Are they always going to end up in the middle like that? Not necessarily. But a lot of times you will see the same patterns emerge. 14x and negative 3x, when I add those together, I get positive 11x. Over here I got 2x squared. And over here I have negative 21. So there's my resulting polynomial. Now, as we get on to future lessons and what's called factoring, I told you this one we're going to learn how to go backwards and figure that out. That's actually pretty simple to do. You're going to notice some pattern recognition that just it leads you right through it. This one, on the other hand, even though they came from the same spot, this one is a lot tougher to see because this 2 over here really screws things up in terms of noticing the patterns that are there. So we'll get to that at a later date. Right now, I just want you to be able to expand these out, and that's what this means. When I multiply them, I'm expanding them out, so there's no more grouping symbols. It's just a whole bunch of terms put together into a polynomial.